just there.
They're not dead. They're not dead.
How do they not die when they're just saying that?
All right. Okay, today, what we're talking about is we're going to be going through a couple review problems of the whole vector idea, add, subtract, those are easy. We'll kind of talk about that today. You will have to draw some in your homework today. I think there's like 3 problems I'm going to ask you to draw. I'll kind of show you examples of them today. We're going to kind of walk through that. If you want to do a magnitude problem, you will have to find a magnitude for a problem. That's pretty straightforward, pretty easy. And then if they give you magnitude and direction, can we write the normal vector? That's kind of what we're doing. Now, the goal today, other than just doing a quick review, is to introduce the last thing we didn't cover yesterday. I want to introduce, for the first time, dot product. Super easy calculation. The most problem that I've had from previous years is that the classes don't fully understand the reason for it. Today, I'm going to try to give you the entire explanation of it. It's not long. It's actually really straightforward, really easy, but some people, they question like why we do it in the first place. And I'm going to try to show you that today so you're not like always kind of wondering why. And I don't know why. For some reason, this one, even though I explain it I think very clear, some people still always ask questions like, why do we do it? Why do we do it? I'm going to try to explain it.
Why do we do half the stuff?
So, all right. Let's talk about adding and subtracting vectors. Let's do that first. So, on the first one, right? Let's draw a vector from coordinates. So, let's review that. So, if I give you an initial point and I give you a terminal point, can we actually draw a vector or come up with the I and j component for it? So let's say the initial point is -2, -1. Let's say the terminal point ends at
6 and 3.
6, 3? Yeah, that'll work. All right, so let's say that's my vector, right? Can we draw it? Can we get the ij component for it? Because again, this is what I want. So let's call this vector v. Okay, vector v. It's got some I component, it's got some j component. I have no idea what the numbers are going to be. We'll look at that here in a minute. So, the starting point, -2, -1, right? So that's, now, when I label this, you don't have to do this, but I'm going to call this one I, that's my initial. And where I'm ending at 6, 3, 1, 2, 3, 4, 5, 6, 3. This is the terminal point. And when you draw it, the arrow has to face the terminal. That's where I'm ending. I'm going that direction, stopping there. That's what the arrow's telling me. Okay, again, I'm just labeling the I and T for initial terminal. So I kind of know where the arrow needs to go. You don't need to. All right, so everyone get familiar with how the vector is drawn. Okay, I think it's easy. It didn't have to go through didn't have to start in the origin, I can start anywhere. This one looks like it actually passes through the origin. But it didn't have to start anywhere, it could be anywhere on this picture. Now, to figure out the I and j component, we talked about this yesterday. You subtract the actual numbers here. You always take the terminal number and you subtract the initial number. So to get the I and j components, I actually subtract the x numbers, right? So 6 minus -2, 8. 4. And yeah, 3 minus -1, and you get 4. This, what you're looking at, is the I and j component for your vector. That's so if I were to draw this in a different location, all I need to realize is I'm going 8 to the right, up 4. It's positive 8 to the right, positive 4 going up. So I can put this vector wherever I want. That's why we come up with the I and j components, because it tells me the horizontal and the vertical, wherever you want to draw. So it'll be parallel to that one. Okay, questions with initial, terminal, that type of thing. Okay, we could find magnitude of this thing if you needed to. Magnitude, that's an easy number. Find magnitude of v. This is the magnitude thing, right? It's the length of it, how long that stick is when you look at it. The shortcut was you take the I component, you square it. You take the j component, you square that. You add them together, and you take the square root of it. That's how you do it. So this is 64 plus 16. When I add those together, I think I get 80 perfectly. And I take the square root of 80, whatever that is. It's almost 9. It's like 8.99. Make sense? Like that's the length of that stick, the length of the actual vector itself. Okay, do we feel comfortable with some of the stuff we talked about yesterday? I'm just kind of doing a little mini review. I think this stuff is easy. I'm hoping you do too. I mean, that's what you're doing in your homework. So I just want to make sure we get the little nuances, like which way to subtract, because you have to take terminal minus initial, and then how to get these numbers set up correctly. Okay, all right, let's talk about adding and subtracting, just so we know how to draw these things, because I think this makes total sense. I want to talk about how do we add and subtract vectors together when they give you a couple different combinations. So, let's get rid of this stuff. Okay, so let's go with vector v here. We'll go with vector w and vector x. What was vector v we just had a little bit ago? What was that number?
8i plus
8i plus
4j.
4j. And sorry about my i's, they're squiggly. They're supposed to be italics, I can't do that. All right, so I and j. W, let's say that's negative 3i minus 7j, and let's go x here. Let's just go 5i. Okay, so there's my three vectors. Let's say that I wanted to add these together. So I want to draw the representation of w plus vector x. And that's maybe this is the problem that they ask you very explicitly. Find the resulting vector of adding the two together and make a sketch of it. So sketch the vectors. So we have to sketch them correctly. So this is the part where you can start drawing on the origin and then go off of there. Because you can put vectors wherever you want, right? As long as they're going the same direction and the same magnitude. All right. So what letter, so this, hopefully this will explain itself. What letter comes first here? That's the first one you have to draw. You have to start on the origin, draw W from there. So W is going negative 3, negative 7, right? So I'm going to draw that from here. This is my initial point. So negative 3, negative 7. 1, 2, 3, 4, 5, 6, 7. This is vector W. Make sense? Okay. Vector x now, I'm adding it, so I don't need to go the opposite direction or anything like that. I'm just going to add x. So how you add, and since I'm not subtracting, you're going to start at this point, right where you ended, right at that terminal spot, and from that spot, you're going to draw x from there. So x, what is the actual components here for x? It's 5i plus 0j, okay. Now, this is a horizontal, it's positive, so I'm going to the right. And I'm going up and down 0. So from here, I'm going to go 1, 2, 3, 4, 5, up and down 0. There's vector x. 5 to the right. That's how you add them together, right? You put w, you attach x right on it, right where the terminal was. And the final answer, what I'm looking for, this thing, right, is w plus x. This part here is actually this vector right here. This is w plus x. In fact, let me make that a dashed line so it stands out a little more. That vector is the vector when you added the two together. What I'm looking for is the vector, like the final answer, is always avoiding all layovers, like if these were airplanes, right? You know, I was starting in Des Moines, I flew to Kansas City, I went over to St. Louis, right? Instead of going through the layovers, what would be the path that gets you right to St. Louis in the first place? So maybe that it's just this vector. So how you do that, you just add the two vectors together. This is the visual representation of what we're doing. This is the flight path. But the actual results here, when I add, you just add the i's and j components. So I'm going to add these two. I'm going to add these two together, because that's what they're telling me to do. You add the x and y, the w and x. So add the components, what do we get? What do we get when we add the i's? Two i's. So this is 2i. Negative 7j's, so minus 7j. You just put minus 7, you don't have to go plus negative, right? This is the answer I'm looking for. This thing that you're looking at is that green vector. So if I started on the origin, I could have just went 2 over, 7 down, and got to the same location. That's what it's telling me. Okay, it makes sense how to draw, how to like figure out the final answer. The answer is easy, right? But I think most people always get caught up on the drawing. They're just like, God, how do you draw this stupid thing? You just draw the first one, attach the second one to it. And then the final answer is where you should have ended up at anyway. The shortest path. Yeah? Yep. Let's do one more. Let's do one where we kind of mess with it a little bit. Let's do one where like we double it or something like that, where we actually put numbers out front or we subtract. Something where it's kind of goofy. And I want to talk about how that works. So let's do something like this. Let's go like this. Let's go 2 x's, and we're going to subtract vector b off of it. And we're going to try to draw this, like what it's looking like. I'll try to draw it roughly to scale, and then we'll kind of show where this thing's going to go. All right, so what I would do first, like if I was attempting this problem, I was going to attempt to draw it, then find the final answer. I would actually figure out what 2x is as like a vector.
10i.
So yeah, so because what you're doing is you're doing the scalar multiplying, right? You're taking 2 times x. So you're taking 2 times this whole thing. So you're absolutely right. It's just 10i, right? When you take 2 times both numbers, it's 10i. Ooh, geez. What am I doing?
10i 0j.
It's 10i 0j, right? That's the 2x part. That's the vector I'd technically be drawing first. And then in the second part over here, I'm basically going to add -1 times vector b. That's what I'm going to do. I'm taking -1 times vector b because that's a negative in front of the vector. So I'm taking -1 times vector b, and that's what I'm adding to it. So this part here is 10i 0j, all right. And I'm adding, now when we take -1 times b, what do I get?
-8 over 4.
-8i or -4j. So that's -1 times both numbers.
2i -4j.
Okay, yeah, and we're starting to do that. So let's draw this. So when I draw this stuff. This vector first, that vector second, right attached to it. Because I don't think about this, right? These are the vectors that these things are representing. So 2x's, that's this thing. So I start on 0, 0, and I'm going 10 over, up and down 0. This, what you're looking at right here, this is 2 times vector x. That's 2 x's. So actually, it's actually this. It's x and then another x attached to it. There's 2 x's, like back to back. So I'm doing twice the distance. Does that make sense, like what I'm drawing there? You don't need to do that. I'm just showing you like the whole, what it means to be 2 x's. And then this item is -8, -4. So from this location, right where I ended, right where I stopped, I'm going -8 horizontally, so I'm here, and then I'm going down 4. So I'm going back this direction. -8, 1, 2, 3, 4, 5, 6, 7, 8, down 4, 1, 2, 3, 4. That's what this is telling me. Over 8, down 4. This is negative vector v. That's the opposite of v. V normally would go this way. You know, go 8 over 4 up and go that way, but I'm going the opposite of v, going this direction. And so the final result, when I actually combine these two, this thing, what you're looking at, is this vector right here. This is 2x minus vector v. That's what I'm looking for. That is the path I could have taken just to get to that location. Because I flew way out of my way, right? I flew to Chicago, then I came back to St. Louis. I could have just flown straight to St. Louis. I didn't have to go to Chicago first. And what was the result? You were saying it out earlier. Like, what do these things add up to be?
2i and -4j.
2i minus 4j. And that should make sense. That, from 0, 0, I could have went over 2, down 4. So that makes sense. So I can, like, double check for my answer correct. Okay. Makes sense? If you can follow that, that's a tough problem to me. Like, visually, like, representing that, that's a tough thing to, like, wrap your head around. That you're doing 2 x's and then you're going the opposite of where b is going. I think this is the easy way to explain it. You find this vector by itself, draw it. Find this vector by itself, draw that one, attached to it, and then it combines like common sense. I think there's only 3 problems you're going to have to draw today. It'll be something very close to that. That's like one of the tougher problems.
That was easy.
Okay, good. Good to hear that. All right, now, let's do one of the last review problems, because obviously this is stuff we did yesterday. Adding vectors, subtracting vectors, scalar multiplying. Now, there was one problem I think we finished class with yesterday, where I was using magnitude and direction to write the component form. So I want to do that problem right now. So let's say we're going to draw a vector. We'll call it vector z, where I'm given the magnitude of vector z. Let's say that's 10. So it's 10 in length, and the angle it's making is a 26-degree angle. It's just kind of a random number I picked. And I want to draw it. You will not have to draw it, but I'm going to draw this roughly, and then I'm going to try to figure out what the I and j component thing is for this thing. So like, how would I write the vector? So write that down, and we're going to draw it here in a second. Stuff the camera here. Now, let me do a rough sketch what this thing looks like. This whole magnitude idea is how long the stick is. So it's 10 units long, right? And it's going at a 26-degree angle from the x-axis. So, because again, we start on the origin here. I'm going 26 degrees this way. So that's, I don't know how roughly what that is. And I'm going about 10 units long. So let's say that's 10 actual units long. That's length of 10. I want to know what is the I and j component for that vector. Like, where did that end up at? Where did that final terminal dot land? And that's what I'm finding. I'm finding vector z, the I and the j component. So I'm expecting it's gonna land in the first quadrant somewhere. Because it went 26 degrees up, 10 units that way. So I'm hoping it's somewhere in that range. Okay, now to find this, we talked about this yesterday. You take the magnitude of z times the cosine of your angle. That will give you the I component. That will give you your horizontal distance you're going to travel. And then you take the magnitude of z times the sine of your angle. And that will give you the vertical component. Now again, why? Because I know maybe if you're gone, you're like, why did you come up with that for me? Because this is going to mimic a right triangle, if you look at your picture. You know, I have this angle here, this is my 26 degrees, this is the 10. I'm finding this number and this number, the x and y component, the horizontal and the vertical. And the way that we do that, we use trig functions. Cosine of 26 is x over 10, so we multiply the 10 across. That's my magnitude. This is the angle. So when I do cosine, it's adjacent over 10. That's why that's the x component. It's the x over 10. And when I multiply because when I set this up, cosine of 26, it would be adjacent over the magnitude, and I multiply this across. That's what I'm getting here. That's the x number by itself. Okay, so the magnitude of z, what is it again?
10.
10 times cosine 26.
8.9879.
Say again?
8.9879.
879 I. That's my I component. It's about 89-ish across. Plus 10 times the sine of 26 degrees.
4.3837.
3837. That's fine. There's my ij component. So it's roughly about 9 over 4.3 up. I was actually really close. Actually really close. I was a little bit too long. Should have looked a little bit. So not bad for a guesstimate.
So proud of you.
Okay, all right. Makes sense what you're doing? I think you only have like one of those. So you just plug the numbers, use your calculator. You can use calculators for that problem. Make sure you're using it. I want to know what the I and j component is. Make sure you're writing this stuff down so I kind of know how you're coming up with the number. Are you using the sine, using the cosine, are you using it correctly? Are you using the right numbers in the right spots? Okay. All right. Last part today. So absolute last thing today, dot product. I'm going to show you the dot product formula, which is goofy. Then I want to explain what it is, like why do we have it? Because sometimes that really messes with people. Okay. Okay, we good with that from them?
Yep.
All right. So let's get rid of everything here. All right. So last thing today, talk about the dot product. This is what the dot product looks like as notation. They're going to take two vectors, vector v times vector w. So what does that symbol look like? Dot, right? That's the notation. It's called the dot product. That's why they use dot. To me, it looks like multiplying. I mean, I even said it looks like v times w. That's actually the dot product. We don't actually multiply vectors together. We add them and subtract them, right? We can do scalar multiplying. Does that make sense drawing-wise? But what this is doing is something a little bit different. So let me show you what the formula is. Then we'll plug numbers in. I'll explain. Okay. So so if vector v here, I'm just going to make up letters. So let's say this is let's say that vector v is ai plus bj, and vector w is ci plus dj. So those are my vectors, right? The A is the I component, the B is the J component, the C is the I component, the D is the J component. So how you find the dot product, like this thing right here, you actually take the A times C. So it kind of looks like you're multiplying, right? And that's what you're doing, right? You're taking A times C. But then you add, which I know is weird, you add B times D. So you're going to multiply the I components. You're going to multiply the j components. And whatever that number is, like for both of those, you add those results together. That's how you find dot product. That's all it is. That's dot product. So let's plug in some numbers here. So let's say, I'm just going to make up some numbers here. Actually, I'll let you guys pick up numbers. So
17.
Okay, so let's go 1 and 7. I'm going to go 1 and 7 for 17.
38.
3 and 8. All right, let's do that. Okay, so these are my vectors. So we're going to plug in the numbers here. So 1 times 3, because I multiply the a times c, right? So multiply the I components, so 1 times 3, plus the 7 times 8. So this turns out to be 56. This turns out to be the number 3, and when you add them together, what do we get?
58. I don't even know.
59. All right, you get 59.
What?
It's a number, right? It's just a digit. The hard part is, what does that mean? Okay. Yeah, for most people, they're like, what is that? It's not even magnitude. Don't get me wrong, it's not magnitude. What that is, it's a shortcut for finding the angle that's in between the two vectors. That's all we use dot product for. It's a quick way to find an approximation of the angle between them. And I'll show you what we can do with this. So let me actually draw these vectors. I'm going to draw vector v and vector w, and they're going to start at the same spot so you can see that they're going two different directions. In fact, I'll do the top one in blue. I'll do the bottom one in green. All right. That way we can kind of see the two vectors, right? All right. So the top one, 1 over 7 up. 1, 2, 3, 4, 5, 6, 7. We're starting on 0, 0. So this is vector v. There's vector v. Vector w, put in green here. That's 3, 8. And we're starting here on the origin. And this is vector w. And what this number is, it will help me find the angle in between them. It'll actually help me approximate it. Now, when you look at that picture, angle between them, big or small?
Small.
Really small. Like really small. I'm expecting that number 10 to 20 degrees-ish. You know, guesstimating what that is. Okay, 10 to 20, somewhere in that range. Small numbers, right? Now, how do I know that? If this number, when you do the dot product, if this number is positive, which it is, right? It's a positive 59. If it's positive, your angle that's in between the two vectors, when you draw them like I did, where you start on the origin, you draw them their two directions, your angle will be acute. It'll be really small. It'll be smaller than 90. Now, I don't know how small it will be. It won't tell me that until later. We're going to see a second part. But right now, we know it's going to be small. We could have technically used this on some of our homework previously to like kind of guesstimate, are my numbers going to be big, small, you know, that type of thing. But you need your coordinates in all those locations. That's the tough part. Because I have my coordinates, like where I'm going. All right, now, if the number turns out to be negative, you know, this number, so instead of 59, it turns out to be negative 59. It's obtuse. The angle between them would be really big. It'd be bigger than 100, or it'd be bigger than 90. Right? Now, what's the one occasion that I didn't label?
If it's right on, like, 90.
Yeah. If it's 0, like perfect 0, like when you add these together, it makes 0, you have a 90-degree angle. You have a perfect right angle between them. Now, why that's important? If it's right, or perpendicular, or orthogonal, whatever you want to call it, right? Whatever that angle is. If it's 0, you could just do SOHCAHTOA on this problem. You wouldn't need to do, or you could do Pythagorean theorem. You would not need to do law of sine, law of cosine, all that good stuff. Because it's a right triangle. It has 0 for a dot product. That's why we use this check. Now, when most people see this, they're like, okay, fine, right? We did the checks, we kind of know what type of angle it is. But this number doesn't tell me what the angle is. It's not 59 degrees, it's small, we can see it. That's where we have the second part of the formula. So, questions on the dot product right now. Second part of the formula now. This is the second part that I'd like you to have written down. The dot product has a secondary formula. So the dot product is equal to the magnitude of V times the magnitude of W cosine angle in between them. That's the second formula for the dot product. So now we can figure out the angle in between them. We're going to plug in my numbers and we're going to actually walk through this so you can see it. And I think this is pretty straightforward. So we already did the dot product. What was my number for the dot product on this problem? 59. So we're going to plug that in, that goes here. That's the 59, that's the number we just found, that's the dot product. Okay, that's equal to magnitude of V. So magnitude of V, V is over there. How do we do magnitude again? What was the rule? Okay, x minus x, y minus y, or the shortcut, square root 1 squared plus 7 squared. You take the I and j component, you square them, add them together, you take square root of it. That will be the magnitude of V. That will be a decimal, it's fine. Okay, magnitude of W. Square root, what are the numbers for W? 3 and 8. 3 squared plus 8 squared. In the square root. Times the cosine of the angle between them. And that's the number I don't know. I don't know the angle between them. We're trying to find that. Okay, so is everyone comfortable with the magnitude? We did that earlier. That was the stuff we did yesterday and today. Okay, 1 squared. 1. Plus 7 squared, so that's 1 plus 49.
50.
So we're doing the square root of 50. That number roughly, square root of 50 is just above 7. 7.1 or something like that. Okay, 3 squared. That's 9 plus 8 squared is 64. When we add these together, we get 73. We're taking the square root of that. That number is just above the number 8. 8.5. Cosine angle in between. And on the other side, we have 59. Okay, so does everyone understand where I'm coming with these numbers now? I need somebody to multiply those two square roots together. The root 50 times root 73. Here's what I'm expecting. This number, when we multiply them together, this number will be bigger than 59. 60. Okay. It was at 60 point something?
I just roughly did it, 60.104.
104, okay, that's fine. Now, the reason why it had to be bigger than 59 is when I divide that 60 to the other side, I need a number that is definitely less than 1. On the other side, this number over here has to be less than 1 when I take the cosine to the other side. Because that's how I find angles. When you do the inverse cosine, all numbers have to be less than 1. So, divide this over, what do we get? 0.9816, that's fine. So we divided that number over, right, because we divide because it's attached to the cosine. And now to find the angle, we do the inverse cosine button to this other side. So the inverse cosine button is that cosine negative 1 key on your calculator that we use that to find angles of 0.9816. And that'll be my theta, which is roughly 10.59. 99? 9, oh, geez.
No 5.
Oh, no 5. All right. 10.998. 998. All right, that's good. All right, there you go. And I said, I didn't know where it was going to be. When I looked at it, I said between 10 and 20. And I guesstimated what that vector was going to be. It turned out to be 10.9, almost 11. Homework. Okay, homework today. Okay, homework. This homework's going to be a little weird. It's easy. Don't get me wrong. I'll hand out the scratch paper here, the graph paper here in a minute, because you have to draw 3. You only have to draw 3 times. Just watch when they ask you to sketch. I think there's 3 of them. I didn't go in order. I didn't go like, oh, 1 through 10 and blah, blah, blah. I jumped around because I only picked problems I wanted you to do. So I just kind of picked. It seems completely random because I just was picking problems that we talked about in class. So I didn't assign everything because there was like a billion problems. I think this section alone there was like 264 questions in this section.
Extra credit?
No, I've definitely done that in college. I've never wanted to do that. All right, so page 709. Here's the problem from this page. There's 2 pages. I picked page 709 and page 719. The reason why is this was like all like adding, subtracting stuff, magnitude. This was dot product. So there's a couple problems I'm going to throw in with dot product. All right, so the top one is 2, 8, 9, 14, 15, 26. I kind of jumped around. Some of these are like find magnitude. Some of these are draw. Some of this is like find what happens when you need to, the angle between. There's 30, 32, 48, 51, 54. Okay. These problems are where they start like going like 2x minus w, and they'll have you find that. I don't even think they didn't even ask you to draw these. They just have you find what 2b minus w is. So just like the I and j component. Then the second page for the dot product is 2, 5, 10, 17, and 18. I think the first couple, just find dot product. The next, I think next 2 or 3, you have to find the angle between like what I did up there. It looks impressive, it's really not, especially when like, one of those problems is find magnitude. You can do it in like 3 seconds. You don't even have to tell me the square, just say square root of 60. There you go. Tuesday next week, I don't care when, you can turn it. Okay, tonight I'm going to update your grades. So I know some of you did a retake on a test. Some of you turned in late work, whatnot. That'll be updated tonight. I'll hand back homework tomorrow so you can make some fixes and stuff. Remember, you always got a week. Once I hand back stuff, you can make fixes and stuff.
Or if I do all the problems, will you switch to an Android?
No.
If I get all the problems right, will you?
I'd consider it.